Hello, welcome to today's class. Today we have this math Olympiad question before us here. The question is bracket open x all over 3 close bracket all to the power of 3 plus log x equal to 3 times 10 all raised to power 4. What then is the value of x that is satisfy this equation? So if you're new here, this is Math Prowess. Not subscribe. Do yourself that good and equally do us that good by hitting the subscribe button, and when you subscribe, turn on the notification bell so that whenever we release an amazing video like the one you're about to watch now, you'll be among the first to get our videos. So we take first thing first, selection. Okay, so now look at this question. What thing I'm going to do here is to log both sides of the equation, and the base we're going to take is going to be natural base, which is base 10. So we're going to take this side to be log bracket our x all over 3 all to the power of 3 plus our log x, then everything equal to log our 3 into 10 all to the power of 4. Also, we succumb to some of the laws of logarithm that we actually enable us to solve. The first one is the power law of logarithm. Okay, so here it says that if you have your log, your m to the power of, let's take t, then move this to this side. So this is going to give us our t into our log, our m. Remember this law? Okay. So we can apply that here. We could as well do that here, but here we have a product here. So we're going to handle this product first before I apply the law here. Again, the product law says that if you have your log m n, this is equal to your log m plus our log n. Remember this law also? So we're going to use this law also here. So we're going to move this power to this other side and separate this. So this is going to give us here, this now implies we're going to have 3 plus our log x, or in bracket, then bracket our log x all over 3 here. Okay, so let's put our square bracket in here, then equal to our log. Here we have a 3 there plus our log, our 10 all to the power of 4. Again, we're considering the power law here now. So we can now move this to the side. So here we have a division law. And what does the division law say? It says that if you have your log m all over n, this is equal to log m here, then minus log n. Fully remember this law also? Yes, so here we can apply it here. So this is going to give us bracket our 3 plus log our x, then close bracket into our log x minus log 3 close bracket. Everything now be equal to log 3 plus 4 log 10. Now recall we said at the beginning that we are using log base 10, which is our natural log. So here we have base 10, base 10, base 10, base 10, and base 10. And remember the log, we say that if we have log a base a, this is equal to 1, provided a is not equal to 0. So you can remember this law also. So we can apply that law here now. So the whole of this will give us 1. So we end up having our 3 plus log x close bracket into our log x minus log 3 close bracket equal to our log 3 plus our 4. Good. So what do we do next here now? We want to move all the terms on the right hand side to the left hand side, and at the same time use this bracket to open up this bracket here. So let's go ahead and do that. Use 3 to times this will now give us here our 3, then log our x We equally use this 3 to times this. So this might give us minus 3 log 3. Then we come to this term, we use this to times this. This might give us plus log x r to the power of 2. We use this to multiply this. This will give us minus log x bracket our log 3 bracket plus. We are moving this to this side, so this will give us minus log 3. Then this will turn to minus 4 equal to 0. Good. There are some things that are common here, okay? But before we can do that, to reduce this equation to a very concise or a visible one, we have to do some substitution here. So we can bring in another alphabet to represent our log x. So we can say here, let's take p, let p be equal to our log x here. So we can write this to give us our 3p, then minus 3 log 3, then plus p to the power of 2 minus our p into log 3, then minus log 3, and minus 4 equal to 0. Wow. So the equation is not clear here now. We can now bring out this having the highest exponent, p to the power of 2. So this might give us p to the power of 2. Okay. Then we have 3p here. We also have another term that has p here. So let's bring the two together. So we have here plus our 3p minus p log 3. Here we have minus 3 log 3, and we have here minus log 3. So we can put the two together to give us minus 4 log 3. Then we have this left here, so we have here minus 4 equal to 0. So what we do next here is just to factor out p from this system here and factor out 4 from this system. So we have here p to the power of 2 there plus bracket 3 then minus log 3 close bracket into p minus 4 into we have log 3 plus 1 equal to 0. Okay, now look at this. What can you see from this expression we have here now? This is a quadratic equation in P. So we have to solve this quadratically, and again, we cannot use the factorization method here. So we want to resolve to, I'm using the formula method here. We bring out our formula. What does the formula say? We know that the formula is P is equal to minus B plus minus the square root of B squared minus 4AC everything all over 2A. So we bring out our A, B, C from this expression. So our A is equal to positive 1, which is the coefficient of P squared, and our B is the coefficient of P, which is our 3 minus log 3. Okay, let's put it in bracket, and our C is the constant term here, which will have to be minus our 4 into our log 3 plus 1. Oh, this might give us some challenge, but we're going to get to the root of this. So what we do now is just a matter of substituting into our formula. So let's go ahead and do that. So this now implies that our P will now be equal to, what is our B? Look at B here. So I have minus bracket 3 minus log our 3 close bracket plus minus B is square root. So let's draw this, extend this very well. So we're going to have here bracket 3 minus log 3 all to the power of 2. So we're going to give us here minus here 4 into 1 close bracket, then bracket. Here we're going to use the square bracket because of this here, okay? Oh, sorry, this is a bracket here, please. So we're going to have here minus 4 there close bracket into log 3 plus 1 close bracket. Everything all over our 2 to 1. So from here, we can use this to open up this. So this is going to give us here our P will now be equal to this will give us minus and this positive. So we're going to have this to be log 3, then minus 3, okay, plus minus the square root. Here we can open up this. If we open up this is going to give us here our 9, yes, the minus our 6 log 3, the plus our log 3 all to the power of 2, okay, the plus, if we use this to open up this, first of all use this to open up this to give us minus 4 log 3 minus 4. So if we use this minus to open up along with this constant, it's going to give us plus 16, the log 3, the plus 16. Everything all over our 2. Okay, so with this, what comes to mind again? We can just collect terms together. So this is going to give us here our log 3, then minus our 3 plus minus. Here we have the square root. Yeah, let's start with this. So we're going to have this log 3 r to the power of 2. Here we have minus 6 log 3 and plus 16 log 3. So this will give us plus 10 log 3. Then 9 plus 16 will give us plus 25. Okay, everything here all over our 2. Easy. So what we do next here is easy. We can rewrite 25 as 5 to the power of 2. There's a reason for doing that. It will soon be clear to us. So we have here log 3 minus 3 plus minus into square root of log 3 all to the power of 2, then plus 10 log 3, then plus 5 to the power of 2. Yeah, then everything all over 2. Now check out this expression we have here now. Remember the algebraic identity which says that if you have your a plus b all to the power of 2, this is equal to a squared plus 2ab plus b squared. Remember this very well? Okay. So if you remember this, look at what we have in here. We are having a similar expression of this kind here. So we can rewrite this expression as, so let's go ahead to give us a p will now be equal to our log 3 minus 3 plus minus the square root of bracket open log 3 plus 5 all to the power of 2. Everything all over 2. So if we use this to open this, we're going to come up with this. So this is a radical and if we go with this, so from here, this is now going to give us here our log 3 minus 3 plus minus. Here we have log 3 plus 5 all over 2. We have two case scenarios from here now. So this is going to give us here our P1 will now be equal to log 3 minus 3. We take the plus sign, which is plus here log 3 plus 5 all over 2. This is equal to, here we are having log 3 there plus log 3. So this will give us here 2 log 3. Then minus 3 plus 5 will give us plus 2 all over 2. We can factor out 2 from here, right? So if we do that, it's going to give us here our 2 into log 3 plus 1 plus bracket all over 2. Cancel, cancel. So this will now give us log 3 plus 1. So we now have, therefore, our P1 is equal to log 3 plus 1. So let's keep this now. We look for our P2. So P2 is going to take the second case scenario, which is going to be the minus here, right? So we have our P2. Our P2 is going to give us here log 3 minus 3, the minus our log 3 minus 5 all over 2, because have in here now. We use this minus to open up this. So we're going to come up with this. And so this will now give us here our P2 will now be equal to, we have plus log 3 minus log 3. So this leaves. So minus 3 minus 5 will give us minus 8 all over 2. So we end up having minus 4. So therefore, can I say P2 is equal to minus 4. Okay, so we have our P1 to be this, which is log 3 plus 1, and our P2 to be minus 4. Now we recall where we said let P be something. You remember that? Yeah, look at it here. Look at where we said let P be equal to log X. So from here we now say recall. We want to recall where we said log X be equal to P. So we'll now take case 1. So our case 1 is going to give us here our log X is equals to log 3 plus 1. Oh, this is serious. Now, yeah, our 1 could be written as log 10 base 10. Remember that because we said your log A base A is equal to what? 1. So we can replace that here. So this is automatically going to give us log 3 plus log 10. Then remember our product law of logarithm again. What does it say? Look at it here. So record, so with this law here, then we can rewrite this expression here. So this is going to give us here our log x is equal to log 3 times 10. Let's put this in bracket. They are both in base 10. And so what happened is this leave the system, then I have our x is equals to 30. Oh, so this is the first one. So our x is equals to 30. We now look for our P2 to give us our x2. So our P2, which is our case 2. Case 2, we have our P2 is equal to what? Minus 4. Again, we're going to have this to be log x is equals to minus 4. Minus 4 could be written as minus 4 times 1. And 1 could be written as what? Log 10 base 10. And so we can rewrite this as our minus 4 into log 10. Move this exponent to the side of the equation. And so this will end up giving us here our log 10 to the power of minus 4. Okay, again, we have this on the left-hand side. So what happened here, this will leave the system. So if this leaves, we now left with x is equal to 10 to the power of minus 4. This is our x2, okay, and we have our x1 to be 30. Here, I want to do a simple check to check the two answers we solve for. Our x1, we said x1 is equals to 30 and x2 is equals to 10 to the power of minus 4. So let's check if these will satisfy this original equation. So we're taking our case 1, so putting 30 into this. So this will now give us here our 30 all over 3 or to the power of 3 plus log our 30 here, which is equals to 3 times 10 all to the power of 4. Okay, so what we do here is easy. Look at this exponent here. Here, we just have to rewrite this. From here, I just have to divide this down. So this is going to give us here a 10, right? All to the power of 3 plus our log 30 is equal to our 3 into 10 all to the power of 4. So look at this. This is exponent, and here we have sum or plugs. So we can rewrite this in this format, which is 10 to the power of 3, then times 10 to the power of log 30, right? Good. So if we have this, the bases are the same, so we can add the exponent. Hence, we have this. So this and this are the same. This is equal to our 3 into 10 all to the power of what? 4. Here, so long this is to base 10, and we are having 10 raised to log 10 log 30 base 10. So what happened? This will go with this. So we're going to have here 10 to the power of 3, then times 30, which is equals to 3 into 10 all to the power of 4. Easy, right? We can split 30 into 10 times 3. So we're going to have here 10 to the power of 3 times 10 times 3. Then the left hand side we have 10 to the power of 4. Here is to the power of 1. So if we add up the exponents, since the bases are the same, that will give us 4. So we have 10 to the power of 4 times 3 is equals to 3 into our 10 to the power of 4. So if we rearrange this implies that 3 times 10 to the power of 4. And on our right hand side, we have 3 times 10 to the power of 4. So it shows that the first root, which is x1, is equal to 30, satisfy the original equation. So let's do a check for the second root, which is x equal to 10 to the power of minus 4. So we substitute that into our equation. So we have here bracket open our 10 to the power of minus 4 close bracket here, all over 3, all raised to our 3, right? There plus our log 10 all raised to the power of 4, everything equal to our 3 into 10 all to the power of 4. Oh, easy. Here we can apply the exponent law again by moving this way. So if we do that, we'll have here 10 to the power of minus 4 all over 3 all raised to 3. This minus will affect this plus to give us here minus 4, right? Then log your 10. Yeah. So this is equal to, let's keep the right hand side. This is log 10 base 10. Okay, so this will give us 1. Remember the law we did, or we look at the other time. Look at the law here. It says something like that, that log a base a. So this will now give us 1. So we're going to have here 10 minus 4, minus 4 all over 3. Okay, there all to the power of 3, then minus 4. This will be equal to, then if we subtract here, this is going to give us here 10 to the power of minus 4 all over 3 close bracket to minus 1. Let's write this term we have in here now. Okay, we are sticking in the our right hand side. So this is going to give us 1 all over 10 to the power of 4, everything all over our 3, all raised to the power of minus 1 equal to, here we have this down here, which is 3 into our 10 all to the power of 4. So let's continue here to conserve space here. Okay, so now look at what we have here now. This will come to meet this denominator here. So this is going to give us here, this now implies that our 1 all over 3 times 10 to the power of 4 all raised to the power of minus 1 is equal to our 3 there into 10 all raised to the power 4. Okay, now I want to do away with this minus sign here. And so this minus sign will take care of this one and this division sign. So automatically we're going to have this to be 3 times our 10 all raised to the power of 4 is equal to 3. We can open up this to give us times 10 all to the power of 4. 12. So this also shows that our second root, which is x equals to 10 to the power of minus 4, also satisfied the original equation. So this marks the end to this wonderful challenge so far. And so if you learn something from this video tutorial, then give the video a thumbs up. And if you're not clear with any of the steps applied in this question, drop it in the comment section because we are there to reply to all your comments. This is Math Prowess. If you've not subscribed, do it to subscribe so that you get our video first hand once they are released. Bye. Till we meet you in our next video.